Welcome back to the part B of chapter 1. So today we are going to learn about couple. Couple is a pair of equal and opposite forces whose line of action are not the same. And what is the use of couple? When a couple is acted on a body, it will rotate. So here also we can find out what is the moment of couple. Same equation as we have used for the moment of force. Here also we can use the force and the perpendicular distance. So here we are going to find out the moment of couple, that is equal to the either force into the perpendicular distance between the two forces acting on that body. So that will give as moment of couple. And here what is the SI unit of couple? That is same as the moment of force, that is Newton meter. And what is the CGS unit of moment of couple? That is Dyne centimeter. Simple examples of couple. First one is turning a tap. Second one is opening and closing a lock. Third is opening a cap. So by seeing these three examples, you could able to understand what you mean by couple. So next, as here we have learned more than one force acting on a body. And if this more than one force acting on a body is same, what happens to it? Let's check it into that. So now let's see what you mean by equilibrium. Equilibrium of a body is if a number of forces acting on a body and the body is being in the same state of rest uniform motion, we call it as equilibrium. When a body is moving in a path, if the forces acting on it are equal, we call it as translational equilibrium. If a body is turning, or we can say that if the moment of force acting on a body, the clockwise moment and also the anti-clockwise moment, or we can say that moment torque acting on a body is zero, then we can say that the body is in a rotational equilibrium. And what do you mean by static and dynamic? If a number of forces acting on a body and then the body sustains in the same state of rest, we call it as static equilibrium. What do you mean by dynamic equilibrium? If a number of forces acting on a body, then also the body sustains in the same state of uniform motion, then we call it as dynamic equilibrium. Let's check it into the examples of this. First is what do you mean by translational and what do you mean by rotational? So by seeing these pictures, you could able to understand what is translational and what do you mean by rotational. And from this, we can call it as mechanical equilibrium. Conditions when a body is in a state of equilibrium. The conditions are the resultant of all the forces acting on a body is zero, then we call it as it is in a state of equilibrium. And also if the resultant torque acting on a body is zero. So let's see the example of static equilibrium. Consider a book is lying on a table and let's see that the weight of the body is acting downward to the table, and from the table there will be a normal reaction force to the book. They become balanced and there will not be any change. And what do you mean by dynamic equilibrium? When let's see the revolution of the earth, there are number of forces acting on it. That means one is centripetal force or the force between the sun or the earth, and there will be an outward force acting on it, but then also it sustains in the same state. Let's read from this. What do you mean by principle of moment? Just take one simple example of beam balance or a meter scale. And here in this one, if the sum of the clockwise moment and sum of the anti-clockwise moment are equal, then we can say that they are, is what we have to say in this principle of moment. It says that at an equilibrium condition, sum of the clockwise moment will be equal to the sum of the anti-clockwise moment. And this is what called the principle of moment. Basically, how we will find out the clockwise moment? when we are considering a beam and we are attaching a fulcrum to it and we are attaching two slotted weights on both the ends of the beam. So here, if you are taking one side of it and here the moment on clockwise, we will be taking the fulcrum and the line of application of force, and that will be the perpendicular distance, and also the force acting on it will be equivalent to the weight of it. So here, from the principle of moment, from this diagram we can see that the principle of moment says sum of the anti-clockwise moment is equal to the sum of the clockwise moment. Method we can use for in the seesaw. A person who is sitting nearer to the fulcrum with more weight can be balanced with another person who is less weight, who is sitting afar on the other side of the fulcrum in that seesaw. So here we are using our principle of moment. What do you mean by uniform circular motion? The uniform circular motion means, from that word itself you can identify what do you mean by circular motion. If a body is moving in a circular path, then we call it as circular motion, right? And that means uniform circular motion means if a body is moving in a circular path with a constant speed, we call it as uniform circular motion. And what is the main characteristics of this a particle moving in a uniform circular motion? And this body will be having constant speed, but at each point in the circle it will be having different direction. That means if the direction is different, it is having different velocities or it is having variable velocity. And you have already learned, if a body is changing its velocity, we can say that it is accelerated, right? That means if a body is moving in a uniform circular motion which is having constant speed, then also we have to say it as it is an accelerated motion. And the acceleration needed to a body to sustain in the uniform circular motion, we call it as centripetal acceleration. And this will be acted towards the center. And there will be a tendency of a body to fly away from this when we are removing the centripetal acceleration or the centripetal force which causes centripetal acceleration. And that force we call it as centrifugal force. It's an fictitious force. This is what says about uniform circular motion. What do you mean by center of gravity? As you are all students, you once or twice in your life you must have tried to balance your book in your hand, right? Or with one finger you must have tried. Only less have achieved or been successful in handling the book with one finger, or they can balance the whole weight of the book within one fingertip, right? And have you ever thought about what it is? Why they can only do it? Let's see into this. And here, that's what here says about center of gravity. And center of gravity is the point at which the weight of the body acts, or it is concentrated at that point. And what do you mean by weight? With which the earth attracts the body towards its center. That means if there is a force, there should be some point of application of the force. When a body is considered, the weight of the body is concentrated at that point, or the point at which the gravity acts on that body. It depends upon the shape of the body or how the mass is distributed. Here we are going to check the center of gravity for regular shaped bodies. The uniform road, you can see from the figure of the object. If we are applying the force on this object only at the center of it, that means midpoint of the road, we can balance it. Let's see the next object, circular disc. So in this circular disc also we can see that here the center of gravity is at the geometric center. That means if you are applying a force on this point, we can balance this, right? And here you can see the sphere. The center of gravity of this sphere is geometric center of the sphere itself. When we are considering a cylinder, the midpoint on the axis of the cylinder is the center of gravity of this object. If you are considering some extra regular bodies, I am going to denote it because as this is very important for your board exam. And here we are seeing a circular ring. The center of ring will be the center of gravity of this ring. And when we are considering a rectangle or parallelogram, we can see the point of intersection of the diagonals will be the center of gravity. And when we are considering a triangular lamina, the point of intersection of medians is the center of gravity. When we are seeing the hollow cone at a height h/3, from the base on its axis will be the center of gravity. If you are considering a solid cone at a height h/4, from the base on its axis will be the center of gravity. If you are considering a cube or a cuboid, at the point of intersection of diagonals will be its center of gravity. So now all are clear about some regular shapes, right? And also the center of gravity of this regular shape. Let's check if you are getting an irregular body. How we will find out the center of gravity of this? Just by doing some experiment. You can just suspend it at two different points and draw the particular line to it at which it comes to rest. Denote one point on the regular and hang it or suspend it, so that at which point it achieves the state of rest when we are suspending it. Please draw a line to it. Again change the point and again draw another line for it. Similarly, if you are drawing 2 or 3 lines and where this line intersect, and that point will be the center of gravity of that irregular shape. From this video you have learned about couple, equilibrium and principle of moment, uniform circular motion, and also the center of gravity of regular and irregular bodies. Mainly the center of gravity depends upon the mass distribution or the shape of the body. So I think you are all clear with these topics. Thank you.